Uh,
Tofik and other people.
yes, sir. I think Sumesh and Tofik had the videos. But it cannot be overridden, sir. Like once I'm sharing the screen, videos cannot be played at the same time. So, since this is an
Can I
introductory,
start video, ma'am?
yeah, please, please, please.
Your career begins here at Satyabama Institute of Science and Technology, a deemed to be university, a nationally recognized and globally acclaimed destination to accomplish your academic aspirations. The Colonel Dr. JPR Research Park, along with the International Research Center, houses advanced research facilities that have 13 centers of excellence, 10 plus technology transfers, 100 plus patents, 10,000 plus reputed publications. The Satyabama Center for Advanced Studies is a state-of-the-art facility built with the aim to cater to the futuristic aspirations of our students with the aid of a metaverse studio, drone labs, makers space, media center, advanced characterization facilities, ICT-enabled classrooms, and supercomputing laboratories. The engineering departments are equipped with sophisticated infrastructure, fulfilling the academic and hands-on requirements of our students. The architecture department is furnished with sophisticated design studios and spacious drawing halls, all of which support the learning process of our postmodern generation architects. The Satyabama General Hospital, along with the School of Dental, Nursing, Pharmacy and Physiotherapy, have advanced clinical facilities. The monumental Central Library houses a diverse collection of books, periodicals and journals. Additionally, it also has an open-air theatre with a seating capacity of 1,000. The Management, Arts, Science, Law and Hotel Management departments comprise of all the necessary and required facilities, creating the perfect ambience for our far-sighted students and catering to their skill set needs with the end goal of equipping them to live their dream. Our chain of laboratories with practical exposure equips our students to build a successful career. Our institution has a team of dynamic and outstanding teachers who are ever reachable to our enthusiastic students, promoting the spaces to learn and places to grow. Greenery around the campus greets and accommodates our students, who are the backbone of a developed nation, edging them on to achieve the summits of their success. Satyabama Institute of Science and Technology.
Thank you, Ram. Please play the next video. please share the MSc video once more, and then we'll begin.
Your career begins here at Satyabama Institute of Science and Technology, a deemed to be university, a nationally recognized and globally acclaimed destination to accomplish your academic aspirations. The Colonel Dr. JPR Research Park, along with the International Research Center, houses advanced research facilities that have 13 centers of excellence, 10 plus technology transfers, 100 plus patents, 10,000 plus reputed publications. The Satyabama Center for Advanced Studies is a state-of-the-art facility built with the aim to cater to the futuristic aspirations of our students with the aid of a metaverse studio, drone labs, makers space, media center, advanced characterization facilities, ICT-enabled classrooms, and supercomputing laboratories. The engineering departments are equipped with sophisticated infrastructure, fulfilling the academic and hands-on requirements of our students. The architecture department is furnished with sophisticated design studios and spacious drawing halls, all of which support the learning process of our postmodern generation architects. The Satyabama General Hospital, along with the School of Dental, Nursing, Pharmacy, and Physiotherapy, have advanced clinical
A very good morning to one and all joined here today. So we will be beginning with the Ocean Research Knowledge Series. So before we begin, a very warm welcome to all of you who have joined us virtually here today. The Ocean Research Knowledge Series is a 30-hour scientific lecture program organized by Center for Ocean Research and National Facility for Coastal and Marine Research, Satyabama Institute of Science and Technology, on the occasion of 20 years of research excellence of Center for Ocean Research since its inception in 2007. Today, we have with us Dr. Inbakandan, Professor and Head, Center for Ocean Research, who will be beginning the first lecture series on biofouling and control. Welcome, sir. Over to you, sir.
Thank you, Soumya, and other people who are all being moderating this session. And before I want to go ahead with the title of this today's presentation, I just want to give a glimpses about what is Center for Ocean Research. Is my screen visible, Soumya?
Yes, sir. It is visible, sir. Yeah.
Is it in the presentation mode?
Yes, sir. It's in full screen and it's visible clearly. Thank you.
Yeah, thank you. Good morning, all. I'm Dr. Inbakandan, who is heading the Center for Ocean Research. I'm working as a professor of research here. And I'm really happy to introduce about myself as well as about our center. We all know Satyabama Institute of Science and Technology is one of the premier research institute, and we have more than 15 plus research centers. One among the center is Center for Ocean Research. It is a joint initiative with National Institute of Ocean Technology, and it is incepted in 2007. And the people who are all not knowing where Satyabama, actually we are in Chennai, especially in the IT corridor of Old Mahabalipuram Road, that is called as Rajiv Gandhi Sale. And Center for Ocean Research, as I informed that it is incepted on 2007, and we are focusing mainly on marine science research, innovation, societal outreach, and education. And we are more specialized towards marine biotechnology, nanotechnology, ecology, mariculture, and marine engineering. And we are strengthened by different kind of or with more number of national as well as international project supported by DBT, DST, ICAR, MOES, DAE, VRNS, UGC, as well as international fundings like IFS, Takeda, and other things. And our main motto is to promote coastal community empowerment through aquaculture, especially seaweed, as well as uh, eco-friendly aquaculture, as well as artemia farming. And we are also focusing towards the development of and patenting some of the technologies which is giving a sustainable solution in the mariculture and aquaculture application. And we are always conducting hands-on training, workshop, and public outreach for the benefit of students as well as the professionals. And we always support policy development as well as marine resource governance for the nation. And actually, this particularly this ocean knowledge series, which we are beginning, actually coming 2027 will be the 20th year for us. So almost 2 decades for Center for Ocean Research. And to commemorate those 20th year, and we have launched our MSc Marine Biology program. This 2 decade just will tell what is the strength and what is the facility we are having for this MSc Marine Biology program. That's what we are doing this series. And our recent achievement is we have joined hands with the National Institute of Ocean Technology, and NAOT have developed their lidar-based data voice, which is an indigenous data buoy developed by NAOT, and they have tested that in our JPR fishing harbor at Puttam. Actually, Center for Ocean Research is having a Satyabama Field Research Station, and which is managed by our university. So the complete testing was happened there, and it is a successful one. And other success, what happened in the 2026 is we are the certified NABL lab of our National Facility for Coastal and Marine Research. So our labs are certified, and I want to say that students who are going to join this MSc Marine Biology program are going to be trained in that NABL certified lab. That is one more advantage for the people who are going to join this course. And I just want to brief about the Center for Ocean Research roadmap. Actually, it is incepted on 2007 as a joint initiative with the National Institute of Ocean Technology as an India's first blue biotechnology research hub for the benefit of students as well as researchers. On 2009, we have started our seaweed farming. That is the first initiative activity which we have done with the in association with Aquaculture Foundation of India. Most of the people know that the former director of MPIDA and president of Aquaculture Foundation of India, Dr. Shaktivel sir, guided this particular seaweed farming activity. And this complete seaweed farming activity, the operational cost and other things will be taken care by our founder chancellor, Colonel Dr. JP sir, for his own native village. So the entire Muttam village people benefited out of that, and most of the women, so especially we have formed women self-help group, and all the women are getting empowered in this seaweed farming program. On 2012, we have recognized by the DST, NSTEDB, and Satyabama got Satyabama Technology Business Incubator. And very specially, I want to mention that this particular technology business incubator will help and focus on marine bioresource utilization. People who are all want to make some kind of a product from marine biology, aquaculture, and fisheries, we are supporting them. And one more point I want to add here, those students who are all going to join this MSc Marine Biology program, they are also going to be trained in such a way they can come with their own startup. So that is a unique way. If they are going to join in the Satyabama Institute of Science and Technology and Center for Ocean Research for this MSc Marine Biology program, they will be parallelly trained in the Satyabama Technology Business Incubator to become an entrepreneur also. On 2015, Satyabama Research Park has been established with actually the former secretary Dr. Shailesh Naik sir have uh, inaugurated this facility. And this particular Satyabama Research Park is having all the other centers like Center for Remote Sensing, Center for Earth and Atmospheric Science, Center for Drug Discovery, Center for Aquaculture, Center for Animal Research and Technology. The motto is somebody who is dwelling into ocean, they are coming with some kind of a product or anything, they can develop their product in Center for Ocean Research. And they want to do some kind of a R&D in drug, they can use the drug discovery center. And they want to work on anything related to earth and atmospheric science or remote sensing, they can utilize the Center for Remote Sensing and Geoinformatics as well as Center for Earth and Atmospheric Science. And if they are coming with some kind of a drug or any kind of a novel molecule, they can do the testing in the animal testing center. And finally, if they already develop the product at TRL advanced levels, our Satyabama Technology Business Incubator will help them to move their product at the marketable way. That is the motto of Satyabama Research Park. In that manner only it is being an umbrella in our campus. On 2018, again, we got a great recognition with Ministry of Earth Science. Actually, Center for Ocean Research is recognized as the nodal cell for marine biotechnologies, biotechnological studies. We have established the Earth Science and Technology Cell with the collaboration of a National Institute of Ocean Technology and CMLRE. This particular Earth Science Technology Cell is having all the needed instrumentation to do any kind of marine biotechnological research, and it is in-house in Center for Ocean Research. People who are all joining for this MSc Marine Biology program, they can utilize such kind of advanced instrumentation structure if they want to go for marine biotechnological based studies also. On 2019, we are recognized by the Department of Biotechnology, and we have launched our Skill Vigyan Center, and we have done a PG program, a PG diploma program in fishery food product technology also. On 2022, actually, the Satyabama Ocean Research Testing Facility has been established, and this is inaugurated by the former secretary, Dr. Ravichandran sir of Ministry of Earth Sciences. This particular testing facility is having, it's a small hatchery. So we can make an husbandry of any kind of aquatic flora and fauna. And even we have the hatchery technology. Even we want to do any larval culture, we can work on it, or they want to do any kind of a spore settlement or anything else also, they can work on that. And especially I want to say that these kind of facility will be an advantage for the students who are joining the MSc Marine Biology program, because they can nurtured in the living lab. So the aquatic animals, they are being reared, and even reproductive biology as well as larval technology is being already taken care in the field testing facility for especially for aquaculture and fisheries. These facility can be utilized by the students. On 2023, Satyabama Ocean Research Field Station at Muttam Harbor has been launched. Actually, I can say that even if students want to do any kind of open ocean exposure studies like cage aquaculture, or they want to do any kind of environmental impact based assessment on open ocean, they can work on it. And they want to do on post harvest technology or the landings of fishes, because as it is a fishing harbor, we can get a lot of resources. So those marine biology students who is opting this course can directly expose to such kind of stocks, and they can utilize that facility also. Apart from that, we are doing biofouling testing also there in the um, Muttam Harbor facility. On 2024, I can proudly say that Satyabama Institute of Science and Technology has launched the National Facility for Coastal and Marine Research. The tag was given by Ministry of Earth Sciences by the former Secretary, Dr. Ravichandran sir of MOAS. And our chancellor, our chancellor, ma'am, Dr. Maria Gina Johnson, she dedicated that facility to the nation, to the students. So this particular national facility is having all the facility for marine and coastal research. The entire national facility is occupied with the advanced instrumentation to up to from molecular imaging to water quality to microbes, as well as NGS and other kind of underwater labs also. On 2025, Center for Ocean Research is also being part of the nation's flagship program of MOAS, particularly in the Deep Ocean Mission, and almost more than half a dozen of projects have been sanctioned by the MOAS, and all our PA, as well as even myself, as well as our Vice Chancellor also, she is being part of the Deep Ocean Mission program, and we are working on that. And also, we are recognized by the Bay of Bengal program intergovernmental organization, and they are also recognized as the lead research institute. And we are working on the Bay of Bengal transboundary work with the South Asian countries. Apart from that, on 2025, one of our scientists, Dr. Shivraj, has been being part of the Indian Arctic expedition research. And I can proudly say that if students who are all going to join the Center for Ocean Research in the MSc Marine Biology program, they have the opportunity to explore all these avenues. On 2026, we are recognized by the NABL and accredited for our labs, especially water quality labs and other labs has been accredited. So students who are all going to pursue this PG program will be trained in that NABL certified lab, and we are also going to teach them how they can work on accreditation program also. And what is highlight of Center for Ocean Research that is being screened here. In this 20-year, almost 63 plus research project has been completed by Center for Ocean Research. That shows how the scientists or the professors who are all being in the Center for Ocean Research is being trained in doing the research project in their own domain. And apart from that, we are having 15 plus industrial consultancy projects. And the publication is almost 600 plus publications. And we have patented almost 20 plus products as well as designs. And we have developed 10 plus products, which is being supported by the Satyabama Technology Business Incubator. And more than 25 plus MOU has been signed with national as well as international agencies, as well as with non-governmental organizations like NGOs and communities. And the publication have reached almost 7,000 plus citation, and we have our H index is 13 plus, and our I-10 index is 75 plus, and almost 18 plus PhDs has been done their marine biology related doctoral thesis work at the Center for Ocean Research, and almost 8 plus postdoctorals also done their ocean bioscience or aquaculture and fisheries related postdocs here. And we can proudly say that more than 20,000 students have been benefited from our laboratory. They are trained here, from externally. I'm not talking about the Satyabama students. Satyabama students always getting trained in our center, especially students from other colleges, institutes from Chennai, in and around Chennai, in and around Tamil Nadu, as well as from the other states and nations. They are coming and utilizing our facility. And always we used to conduct outreach program, and we have already conducted 25 plus outreach programs, and we have 16 plus international collaboration, and almost we have generated 16 crore of funds for our R&D through the government fundings. And the mission of Center for Ocean Research is to advance fundamental and applied research in marine bioscience, ecology, biotechnology, and conservation, to develop nature-based, climate-resilient, and sustainable solution addressing challenges in marine ecosystem, aquaculture, and ocean health, and to advance fundamental and applied research in ocean and coastal science by leveraging cutting-edge technologies and marine bioresources, to nurture future marine scientists, students, and enthusiasts through hands-on training, research, integrated education, and capacity building program, and finally to foster partnership with national and international institutions, government bodies, industry, and coastal communities for ocean stewardship. And the ultimate vision is to we want to be globally recognized hub for innovative interdisciplinary research in marine and coastal sciences, fostering sustainable utilization, conservation, and restoration of ocean ecosystem through science, technology, and education. And I can proudly say that the Center for Ocean Research is having this much clients like Satyabama Ocean Research Field Facility, National Facility for Coastal and Marine Research, Technology Business Incubator, Field Research Station at Mota, TIFAC Academic Partnership Center. Especially we are working on hatchery industries, DST Fist sponsored facility where we are completely focusing on water, seawater and sediments, and DBT Skill Vigyan program where we focused on fishery food product technology, and MOES ESTC cell where we are focusing on marine biotechnological studies. And our thrust area, it's widely spread like marine biodiversity, taxonomy and bioprospecting, marine biotechnology and blue economy, marine microbial ecology and genomics, aquaculture and marine animal health, environmental monitoring and conservation planning, ocean engineering and restoration, coastal and marine ecology, applied phycology and seaweed research, climate change and health, ocean health, and finally capacity building and student research. And these are all the funding agencies, and we are greatly acknowledging those funding partners, because with their help only we have created a massive infrastructure that will be going to be the benefit for the students. And almost we have generated 16 plus crore of research funding. So we have to acknowledge Ministry of Earth Science, Government of India, Department of Biotechnology, Government of India, Department of Science and Technology, Government of India, National Science, Technology, Entrepreneurship Development Board of DST, and Ministry of Steel, especially SERB. Now it is ANRF and Department of Atomic Energy, NRF, DRDO, ICAR, BOBP, TIFAC, ICMR, UGC, TNSTC, NCSTC, JSPS, Takeda Science Foundation, and many more has to be highlighted here. And apart from that, Center for Ocean Research is being networked with the Center for Remote Sensing and Geoinformatics, Center for Quality Assurance and Non-Destructive Testing, Center for Earth and Atmospheric Science, Center for Laboratory Animal Technology Research, and Technology Business Incubator. So here our research expertise, and we are all governed by our led by our Vice Chancellor, Dr. B. Sheila Raniman. She is though she is a Vice Chancellor, she is completely focusing on marine science also. She is a scientist for AML and image processing scientist. Also, she is the project director for our Satyabama satellite, and now she is also concentrating on the deep sea sciences also. Apart from that, myself, Dr. Inbakanan, I am being the professor and head for the center. And my expertise is focusing on marine biofouling and anti-fouling technologies. I'm also concentrating on larval ecology, sustainable aquaculture nutrition, and also in marine genomics and invertebrate marine biomineralization aspect. Especially, I'm working on molluscan cell biomineralization. This project is funded by Deep Ocean Mission, and I'm working on that. Apart from that, I'm happy to advocate on a nature-based solution for environmental sustainability. And Dr. Stanley Abraham, who is a professor, his specialization in marine microbiology and seaweed farming. And he is also focusing on carbon sequestration through marine ecosystem, as well as bioresources, bioprospecting from marine algae. He is also promoting sustainable utilization of marine algal resources. Dr. V. Ganesh Kumar, who is a professor of research at Center for Ocean Research, and his major thing is chemistry, and he is focusing to explore marine natural products for marine application, as well as he is also studying the artificial reefs and their ecological benefits. Especially, he is working on alternate cements for the larval settlement of coral as well as fish aggregating device. And he is also focusing on drug discovery for a marine organism as well as bioactive compounds for pharmaceutical development. Dr. K. Govindaraju, he is a professor at Center for Ocean Research, and also he is taking care of the Center for Laboratory Animal Research. And his focus is on nanobiotechnology for and marine bioresource utilization. He is mainly studying the jellyfish biology and working on proteomics from jellyfish resources. He is also concentrating on marine-based drug delivery system as well as agriculture application through marine biotechnology. And Dr. Ravi Mani, who is an associate professor of research at Center for Ocean Research, who is taking care of that Satyabama Ocean Research Field facility, which is developed for aquaculture and fisheries activity. And his focus is on microbial diversity, especially he is working on coliforms and antibiotic resistance. He is also focusing on biodegradation and environmental remediation, and he is also developing vaccines for aquaculture disease management, and he is also interested in marine animal tracking for surveillance and ecosystem monitoring. And Dr. T. is Chalandas, who is an assistant professor research at Center for Ocean Research. He is completely working on ecotoxicology and pollution monitoring in aquatic systems. And he is interested in antimicrobial resistance in aquatic environment. And he studies marine metabolites and their ecological roles, and also pollution assessment in mitigating strategies. And Dr. V. Karthik, who is an assistant professor research in Center for Ocean Research. He is a postdoc from Japan. He especially JSPS fellow, who trained in the NIMS of Japan. And he is completely focusing on biomaterial methanobiology, which will be helpful in aquatic sciences as well as in marine biological research. And he is also working on marine faunal cell lines, and he is completely working on artificial meat, especially he's developing fish artificial meats. And his focus is on cellular as well as molecular aspects of marine biology and supports marine biotechnology innovation at cellular level. Dr. C. Kumar, who is an assistant professor at Center for Ocean Research, he is a Rafford Fellow who is conducting research on marine biotechnology and ecology. He is completely focusing on elasmobranch conservation and working on shark and ray biodiversity assessment. And he is also an expert in handling mass spectroscopy, and he is taking care of all the MS instruments in Center for Ocean Research for biomolecular analysis. And he is also interested in high resolution studies of marine organism and ecosystem, especially in the metabolite studies. And Dr. S. Shivaraj, I already informed them. He is a scientist who is focusing on polar science, especially polar science, polar marine biological science. He is an expert in ecological monitoring and environmental impact assessment, and he's mainly focusing on benthic health indicator and ecosystem evaluation studies, as well as he is concentrating on mangrove carbon sequestration, blue carbon research, and he is also integrating ecosystem assessment and sustainable management. And Dr. Thiringana Samandam, he is focusing on marine genomics and host microbe interaction, and he is also working on vibrio biology, and he's taking care of next generation sequencing lab. And Dr. J. Balamurugan, who is completely working on marine chemistry, and he is focuses on mineralogical characterization of marine material, and he is focusing on CO2 sequestration in climate-related activity. And Dr. Srinivasan, who is working on stress physiology of marine photosynthesis organism, and he is heading my marine metabolic engineering lab, and he is working on synthetic biology. Apart from that, he is developing biosensors for environmental monitoring. Sorry, Dr. Govindaraj is being repeated here. Dr. D. Prakash, who is an expert in seagrass taxonomy and micropropagation, and he is focusing on climate change impacts studies. And Dr. Achyutan, who is a macrobenthic ecologist, and especially he is concentrating on ornamental as well as polychaete aquaculture. Dr. P. Maramuthu, who is concentrating on marine wood borer as well as mangrove ecology, and he is completely working on insect-based meal for aquaculture. And Dr. Raghavendra, who is a genomics person, he is completely taking care of all this next generation sequencing based activity at Center for Ocean Research. And Dr. Subhash Chandra Bose, who is a manager and taking care of that NABL organization and other activity, and he is a specialization in biofermentation. I know the time limit is 11 o'clock, but before that, I want to tell what is Center for Ocean Research as the first step. Kindly bear with it. That will help us for the audience to know what kind of facilities available in Center for Ocean Research. And these are all the lab available in Center for Ocean Research, especially marine biotechnology, marine microbiotechnology, applied psychology, proteomics, genomics, mass spectroscopy, which is housed with GCMS and ICP-MS. Also, we have halophyte propagation, microscopy, cell culture, biofouling, proteomics, genomics, and molecular separation lab. We are also housed with material chemistry, biofermentation, spectroscopy, post-harvest technology, bioproduct, and livelihood and skill development facility. And especially in NFCMR, that is the National Facility for Coastal and Marine Research, we have molecular imaging hub where we have a micro CT. Even anyone can access this micro CT, especially we are working on aquatic atlases, and we have a bio AFM as well as confocal microscopy. I can probably say that we are the one who have all the three at one laboratory under a single umbrella called NFCMR. And we are in the profiler lab, we have a microscopy, FTR microscopy, where we can do all kind of microplastic related work. And we have a nano and micro indenter. We can work all kind of tensile based work on any kind of marine material. Apart from that, NFCMR is housed with the GCMS-MS as well as LCMS-MS, where we are completely focusing on pesticide, polymer, as well as antibiotic and other kind of marine nanotechnological, marine ecotoxicological sectors. We have a sample preparatory lab where we have CHN analyzer and sediment analyzer. We can do all kind of preliminary work at sample preparatory lab and water quality analysis lab. Manually as well as automatically, we have a we can do water quality analysis where we have house with the auto lab where we have all kind of 11 parameter at a time, and we can work with that also. And this is a NAB accredited lab. We have a toxicology lab at NFCMR where we can work on zebrafish toxic testing as well as other aquatic animal testing also. We have an underwater monitoring lab where we are training the students for scuba and other activities. And as I already informed that we have an next generation sequencing lab where we have all the three platforms like Illumina MySeq, Sanger sequencing as well as nanopore sequencing. We have a cellular agriculture lab where we are working on artificial meat, especially we are developing fish artificial meats. And we have advanced biovisualization facility. This facility is housed with all kind of a bioinformatics platform. We are helping students in genomics and proteomics pipeline, as well as we have all the 11 modules of Schrodinger software so that we can do any kind of docking work here. And we have a microbiome laboratory, and we are having a culture collection almost 40 plus vibrios and other aquatic pathogens and other organisms are being culture collected and maintained at an NFCMR. And this is our Center for Ocean Research facility. As I said, we have a mini hatchery where we can do animal husbandry activity. We have a 1,000 liter and 10,000 liter as well as 20,000 liter capacity of FRP tanks. We have a complete seawater and freshwater filtering system. So water will be filtered and given for any kind of rearing or tailoring any kind of aquatic animal or floral maintenance in this lab. And we have a microalgal facility there. And we are also doing breeding program and larval rearing program. And we have a tubular bioreactor where we are training the students to go for how to utilize renewable energy in producing the microalgae. And we are also having a polychaete aquaculture facility, and we are focusing on invertebrate aquaculture also, where we have a marine museum. And we can proudly say that we are also having a continuous flow centrifuge system, so that we can directly harvest the microalgae, which is cultivated in a large scale. And we are also working on insect meal for as an alternate feed for aquaculture. And we are also training the nearby villages and women for how to do any kind of aquaculture activity in the backyard system with the collapsible FRB tanks. And our Muttam Harbor, this is the one of the harbor which is integrated with all the major facility like boatyard, workshop, lift station, fueling station, berthing facility, action hall, a fish landing platform, ice plant, supermarkets, net shops, everything can be integrated in the best way. And students who are all going to join this MSc program, they will be taken to this particular facility, and they will be given a hands-on training on the post-harvest technology. And apart from that, we are doing seaweed raft culture, and these are the raft system where we are working on seaweed aquaculture. And we have a field research station lab also there, and we can do any kind of marine analytical work at Muttam Harbor. Apart from that, we are having a tie-up with the RGC, and we are working on open ocean exposure studies like cage aquaculture as well as marine biofouling program. And we are also working on outreach and societal engagement, especially we are helping all the fishermen, and we are engaging the students in all kind of activity. And these are all the collaborative partners with us. Thank you. And this particular QR code will tell about what are the facilities available at Center for Ocean Research, Satyabama Ocean Research Field Facility, as well as in Satyabama Field Research Station at Muttam, and the National Facility for Coastal and Marine Research. I know the time is almost running. I'm just coming to the topic of marine biofouling. I'm just giving the intro about the marine biofouling aspect. if possible, I can go ahead with the mitigation measurements, what we are doing at our Center for Ocean Research. So today I'm going to talk about basically about the marine biofouling. We all know that some kind of marine organism, especially when we are walking in the beaches, especially in the rocky shores, we can see such kind of plants and animals sticking onto the rocky environment. If these flora and fauna sticking onto the rocky environment, it may be very ornamental, and it is very good when we are walking in beaches. But it will also occupy the man-made structure, and it becoming a pest to such kind of industrial applications. So these animals are called as biofouling, and there may be two kind of biofouling that may be soft fouling as well as hard fouling. The soft fouling is comprises of soft corals, sponges, anemones, tunicates, and hydrides, whereas the hard fouling is mainly based on barnacles, mussels, tube worms, bryozoans, and seaweed. And these are all some of the pictures to highlight about what is biofouling. You can see the ship hull, the base of the ship hull is completely fouled, and it is now taken for dry docking. And you can see a renewable energy platform that is completely fouled with the barnacles. And you can see a turbine which is used for wave energy generation. The turbine is completely occupied by the kelp seaweed biofouling. And also you can see a data buy which is completely fouled. If these data buys are fouled, even the sensor get fouled and the weight will be increasing. And you can see the bridges, even concrete structures are being fouled. And finally, the underwater structures also being fouled. Biofouling is not only going to be an addition or an attachment to a materials which is man-made, like fish hulls, ship hulls, or any other concrete structures in marine environment, but is also indirectly providing some kind of negative impact for our climate change. They are triggering greenhouse gases because when there is a biofouling in the ship hull, the weight of the ship will increase. If the weight of the ship is increased, the normal sailing cannot be possible in the ship. So any navigator have to add more fuel to increase the speed or the knot of the ship. So when they are adding more fuel, there will be more emission of carbon dioxide that will lead to greenhouse gases. So that is also directly having an impact on climate change. And these are all examples where the power plant industry is being affected because of this marine biofouling problem. Because those power plant industry, especially like Kalpakam, goes where our Madras Atomic Power Station is there, and they are utilizing sea water as a secondary coolant agent. If the sea water is taken into the coolant water circuit, they are having the tendency to develop this biofouling. You can see the tubular heat exchanger as well as plate heat exchanger being fouled with green mussels and other biological entities. And all these oil rigs are being the main focus in especially in coastal and marine environment, and these platforms are also being fouled with such kind of organisms. And cage aquaculture, the net which is being used to cage the fishes or animals being cultured here or also have the tendency to foul. If the net is being fouled, there won't be any kind of a normal water exchange happening in the cages. So there may be some kind of less production will happen due to this biofouling, and that have to be eradicated. And these are all the other thing. You can see a sensor is completely fouled with barnacle, and you can see a data buy which is supported with the solar system also completely fouled with barnacle. And in the yellow color, the wave cage, the tide cage is completely fouled with barnacle. And the lower film, you can see a current meter, which is before and after deployment. When it is deployed, you can see the current meter. And after deployment, it is completely occupied by the goose barnacles. So there is a relation, it's a cycling process. We can say that any material which is being dumped in the seawater, or any material which is having a connection with an aquatic media, the interface, liquid and solid interface, have the tendency of biofouling, and that biofouling have to be cleaned. That is called as antifouling. So this marine biofouling can be classified as microfouling as well as macrofouling. And this microfouling and macrofouling will happen in a sequential manner, which is tabulated here. You can see the process. All the rose colored boxes are representing the microfouling, and the green colored boxes are representing the macrofouling. The microfouling starts with the initial deposition of organic molecule. See, this is nothing but the biomolecules such as carbohydrates, proteins, lipids, and other any kind of secondary and primary biomolecules available in seawater. They will come and stick to the material surface. It may be a ship hull, or it may be a boat surface, or it may be a cage net, or it may be any kind of a underwater tube, or any sensors, or any kind of a concrete platform. Immediately once the water and the surface interface is having the link, within a second this deposition will happen. This is called as initial deposition of organic molecules. And this organic molecule film will be attracted for the bacteria which is present in the aquatic environment, especially in the marine environment. These bacteria have a tendency to attach to the surface. Some may have the firm attachment, and some may not have the firm attachment. So the adhesion may be reversible and irreversible. Those are reversible. There won't be any problem. There won't be any problem in the biofilm formation. But if it is irreversible, there will be a biofilm formation. Once the bacteria started attaching to a surface in a irreversible manner, they develop the quorum sensing behavior, and through the van der Waals force, as well as with the slime formation, they started doing the slime formation activity and EPS secretion. So the entire biofilm will be very sticky, and that will attract the diatom and algae. So the biofilm will be enriched with diatom and algae later in the marine biofilm in the later stage. So the biofilm is very thick with organic molecule, bacteria, EPS, especially polysaccharides, as well as with diatom and algae. When it is rich with such kind of a microfouling, that will be an attractant to the larvae as well as to the spores. Okay, these microfouling, they will give a chemical clue to those larval as well as spores, and they will be attracted by those chemical clues, and they come and settle onto this. Once this larval settlement happen, that will be that is called as succession of larval recruitment, and that will be developed as a biggest macrofouling, and that is called as macrofouling. Okay. So this is the image is taken from a PLOS One journal, especially with the author Martin, who published this paper in 2015. He is just giving a glimpse that the biofilm starts within a minute. I can even say that it will start within a second. And the particle of organic matter will come and settle, then the primary colonizer, then secondary colonizer, tertiary colonizer, and become a macroscopic fouling community. And the microfouling, they are the heroes like bacteria, diatom, and the macrofouling will be taken care by barnacle, green mussel, brown mussel, as well as tube worms. And these bacteria cannot be seen in the naked eye, so we have to work on any kind of stains, or we have to do any kind of lab-based culture. and we have to seek and we should know what is a bacteria. And diatom, we can see through a microscope. You can see a beautiful structure. They are all having the tendency to stick on the fouling surfaces. And you can see these are all the, you can see a camera in the middle of this slide, which is retrieved from the ocean. You can see how barnacle are being attached to on the camera surface. And these are all the barnacles. Even you can, I can say that the Predator movie is being mimicking approach of this barnacle only. So these barnacles, they are mainly having a great shell on the outer surface, and they are arthropod, especially coming in the insect family. And they have a sessile stage where they are firmly attached like this, and they are also having a free swimming stage. Once the adult started uh, doing the reproduction and releasing the fertilized egg in the open environment, it is in a free swimming stage, and the metamorphosis happen, and they will end up with the cyprid stage. Cyprid stage is the stage where they have the pseudopodia with a walking leg that will start walking on the surface, where microfouling is interest with. There they will come and settle, and they will grow as an adult. So this will be the pattern for all the barnacle, and that once the cyprid is being settled in a surface, they secrete the cement protein, and there the biofouling starts. This is the same case for green mussel also. They are also having a free swimming trichopod, develinger, pedivelinger, as well as pad settlement. These pad are the metamorphosis stage where they search for a surface, and they come and settle on the surface and as develop as an adult green mussel. And adult green mussel, once settle on a surface, it is not easy to remove those mussel fouling. Apart from that, even seaweed spores also coming and settling to surfaces. You can see a propeller is completely meshed with the seaweed fouling thing, as well as the tide cage is completely full with the seaweed spores as well as barnacle larval settlement. And I already said that marine biofouling is the biggest menace, and government and industries are almost spending 5.7 billion US dollars annually to prevent this fouling process. This is called as anti-fouling, and it may be a physical cleaning, chemical treatment, mechanical cleaning, and anti-fouling paint-based cleaning. And also nowadays people are also the tributyl tin-based as well as copper-based anti-fouling paints, which is already used before 2003, was being banned in the anti-fouling industry, and now people are working on less toxic metal-based coatings, natural-based eco-friendly based coatings, as well as biodegradable polymer-based coatings, as well as nano-based coatings. And as I already mentioned, that a clean surface which is immersed into an seawater environment, it will lead to a microfouling. That microfouling will provide a slime formation that will attract the bacteria diatom as well as larvae, and that is called as macrofouling. And that macrofouling had to be cleaned. The cleaning process is called as antifouling. This is always happening in the ship industries and other industry where seawater is being used. And I'm just being due to the time constraint, I'm just ending up this slide. And these are all the facilities available at the Center for Ocean Research to do any kind of marine biofouling related research. So we have developed a marine bacterial fouling test, we will do biofilm thickness, biochemical composition, biofilm chlorophyll, as well as ATP analysis, live dead analysis of biofilm, and next generation sequence based metagenomic analysis of microfouling we are doing. And apart from that, in marine diatom fouling, we are working on how the diatom is being adhered to the surface, and we have already developed a technology to count those diatom, and we are also developed technology for live data analysis of those diatom, as well as we are working on next generation based enumeration of marine diatom populations. Apart from that, we are also helping people to test microfouling larvae. We are culturing green mussels as well as uh, seaweed. Here we can work on green mussel spore settlement, so green larval settlements as well as seaweed spore settlement. And we are also helping people to do any kind of field exposure studies in Muntam Harbor. We can completely helping in to test the biofouling aggregation in any kind of testing surface, seasonal studies as well as larval recruitment on, and also we are helping the to know what kind of biomass is accumulating on the surface and what is the weight increment in the surface. And we are also helping people in testing the cleaning efficiency in those surfaces. Apart from that, we are helping people to work on bioinformatics-based platform in working on biofouling as well as anti-fouling studies. I have some more slides also, what we have done in our laboratory, especially on control measurement. We have done some kind of an experiment on nano-based control, marine natural product-based control. We have also developed polymer-based coatings, and we are also we have also developed surface engineer-based coating also. If time permits, I will do that kind of information. I will present those information in next series whenever time permits. Thank you for everyone for listening in my topic in a very patient way. Soumya? Soumya?
Yes, sir. Yeah. Thank you so much, sir, for sharing
Hope
your...
I have
Yes, sir. Thank
hope I
you.
have done the job in the given time.
Yes, sir. Thank you so
Thank
much
you.
for sharing your insights on marine biofouling. And the talk was indeed very scientific. And I hope the students here would have gained deep interest and insights on marine biofouling and its control. And um, our registrations for the Ocean Research Knowledge Series, the link is being shared in the chat box now. So this is an ongoing series which is going to happen every day between 10 a.m. to 11 a.m. and 2 p.m. to 3 p.m. Today, again, for the afternoon session, we have an expert talk on bioprospecting of seaweeds by Dr. Stanley Abraham, Professor, Research, Center for Ocean Research. And we look forward to welcoming you for ORKS 2026 at 2 p.m. again. So you can join through the same meeting link, and registered participants will be receiving free e-certificates. So for further updates and knowledge regarding the training programs and COR activities, please check out our website link and social media link posted in the chat box. And this is to
And one
announce.
more thing, are those registered participants who are all being in this platform, please disseminate this idea to your friends, students, to get the benefit. So this 30 plus program attendance as well as e-certificate will be definitely benefit for the students. So please disseminate and populate this information as well as our marine biology MSc program also to your students. If they completed their UG program in any life science based streams, they can come and see our facility, and then they can also join our MSc Marine Biology program. This Marine Biology program is a 2-year program which we have started from 2026. The main advantage, we have all the needed infrastructure here, and the tuition fees will be 70,000 Indian rupee per year. You can approach us, or you can see our Center for Ocean Research website also for further more information. Thank you.
Thank you, sir. Thank you all. Meet you again at 2 p.m. today for an expert lecture on bioprospecting of seaweed by Professor Dr. Stanley Abraham. Look forward to meeting you all there. Thank you.
Thank
Thank
you.
you, sir.
Thank you.